In this video, we're actually going to be doing kind of an introductory calculus piece. This is called the difference quotient. If you decide to go on to higher math, you will be using this quite a bit when you go into calculus. So it's good to kind of see an introduction to it now, so it's maybe a little bit more familiar next time. So we've got f of quantity x plus h minus f of x all over h is our difference quotient. So let's see how this works with a couple of examples. So as a reminder, here's what we are substituting into to find the difference quotient. So we're going to start by using our function notation. Remember, we looked at this the other day, replacing every x with x plus h. So this becomes x plus h, quantity squared, minus f of x, which is x squared, all over h. Okay, so then we're going to simplify as much as possible. The first thing that we can simplify, I'll move over here so I have more room, is the quantity x plus h squared. Now remember, squaring a binomial does not mean distributing in the square. It means multiplying it by itself. So I'm going to have x plus h times x plus h minus x squared all over h. Then I'm going to FOIL out those two binomials. X times x gives me x squared, and right here, x times h and h times x will give me 2x h's, plus the h times h will give me h squared, minus the x squared all over h. Simplifying, I've got like terms, x squared minus x squared cancel, leaving me with 2xh plus h squared all over h. Now what we can do, there's a couple of different ways to look at this, and I think factoring the h out of the numerator might be the easier of the two ways to look at it. So I'm going to factor that h out of the numerator, so we've got 2x plus h all over h. And now we can see that our h's cancel right here, leaving us with 2x plus h. So this is the simplified version of the difference quotient. If you had a hard time following that, we're going to look at one more example. If you think you got it, you can fast forward. However, this example is a bit more complicated, so I might at least follow along even if you think you understood that. So again, starting by writing down the difference quotient, f of quantity x plus h minus f of x all over h. Substituting x plus h everywhere we see an x in our function, we have x plus h quantity squared minus 4 times the quantity x plus h plus 7 minus, now this time f of x isn't a single term, so I'm going to put the whole function in parentheses. We'll have to distribute that square, we'll have to distribute the minus sign when we start to simplify our numerator, all over h. Alright, so we already saw what happens when we have the quantity x plus h squared, so I'm going to do that part a little bit faster. It's simplified to x squared plus 2xh plus h squared. I'm going to distribute my negative 4 here, and notice it's a negative 4, so be very careful when you keep track of your negative signs when you're simplifying this. This is all algebra, but it's a bit more complicated algebra, so make sure that you are carefully looking at every step. Minus 4x minus 4h plus 7. And now I'm going to distribute my negative sign here to all of my terms. So we get a minus x squared plus 4x minus 7 all over h. Let me give you a little hint when you're simplifying the difference quotient. If in the numerator your terms without an h don't cancel, you did something wrong. You lost a negative, you multiplied wrong, etc. So every term in the numerator that does not have an h in it will cancel with the difference quotient. So right here we have x squared minus x squared. We have negative 4x plus 7 minus 7. The only terms left have an h in them. So we have 2xh plus h squared minus 4h all over h. This time I'm going to show you the other way. I do think the factoring is a little bit easier, but this way, some of you may be able to get it simplified a little bit faster if you can follow this way. So if the factoring made sense to you, factor the h out of every term and cancel it with that h in the denominator. Otherwise, you can use what's called the butterfly method. We call it the butterfly method when there's two terms. When there's more than two terms, it doesn't quite look like a butterfly. But what you can do is you can divide every term by the denominator. So that would simplify to 2x. The h would cancel, being divided by the h in the denominator, plus h, one of the h's would cancel, minus 4. And again, real quickly, for those that didn't quite follow that, I will go ahead and show you the factoring. I think that's an easier visual to see how it cancels. So factoring out the h, we get 2x plus h minus 4 all over h. So these h's will cancel, leaving us with the answer we got. So here are a couple of questions for you to practice. Please come to class with these attempted. What I would like for you to do is discuss the process that you attempted with your group mates and not working through the problem with them. I want you to have it tried when you come to class, please.